initially, but it was experimentally proved that heat is just a form of energy by the famous James Joule experiment, cylinder turning experiment. And in fact, it is a form of energy in transit. Transition means change and generally temperature, but state and phase may also change. Then we have relation between different temperature scales like Fahrenheit and centigrade. So it varies graphically as shown in the figure. Tan theta here is 9 by 5. And for Tk versus Tc graph, tan theta is 1. For Tc versus Tr, the graph passes through the center and the relation is this much. Now we have concept of thermal expansion, which may be linear, aerial or volumetric. Now is the concept of thermal properties of matter. So it's the temperature, and temperature is a measure of hotness or coldness measured by thermometer using different temperature scales. All scales are interconnected, so this is the relation, like we have centigrade scale, Fahrenheit scale, Kelvin scale, Reaumur scale. Lower temperature is 0 degree 32 degree Fahrenheit, 273.15 Kelvin, 0 Reaumur. Upper temperature is 100 degree centigrade, 212 Fahrenheit, 373.15 Kelvin, 80 Reaumur. And if you take the difference, number of divisions are the number of differences between upper and lower values, so you can analyze that these are the number of divisions. Now there is important concept that for all temperature scales, T minus T lower upon T upper minus T lower is constant for all. Now this can be related to any physical property like pressure, volume, length or even resistance of a platinum thermometer. So these are the cases, and this is the relation between various physical quantities. Now there is occurs a concept of heat. So heat can be categorized into two forms, either the specific heat or either the latent heat. Specific heat deals with heat needed to change the temperature. Latent heat corresponds to heat needed to change the state or the phase. So specific heat is given by delta Q is equal to ms delta T. M is mass of the body, S is called specific heat capacity, and delta T is the change in temperature. So from here we can analyze the dimensions of S as M0 L2 T minus 2 Kelvin minus 1. SI unit as joule per kg Kelvin, other unit as calorie per gram centimeter. Specific heat of water is 1 calorie per gram per degree centigrade. For ice we have 0.5 calorie per gram per degree centigrade, and for steam it is about 0.42 calorie per gram per degree centigrade. Now there is important discussion that during melting or boiling temperature is constant, so delta T is 0. So from here specific heat comes out to be infinity. So always do remember, if temperature is constant in those processes, specific heat tends to infinity. So this question has been asked many